Hi everyone! Today, our group is going to present about questions 5. Before that, let us see about the question. Let us see about the A. A is calling us to sketch the graph for the curve y equal to 6x plus x squared. Then, B is saying find the equation of tangent of the curve y equal to 6x plus x squared at the origin and at the point where x equal to 2. C. Given that the two tangents to the curve interact at A, and find the coordinate of A, then find the enclosed area by the tangent and the curve. Okay, let us do about A first. A calls to sketch the graph y equal to 6x plus x squared. Firstly, we can factorize it x out, so become to find the root. So become y equal to x bracket 6 plus x. So we can form the two roots, which is x equal to negative 6 and x equal to 0. Second, we can do about the SC symmetry. SC symmetry, for the x, we can use the formula total of x divided by 2. So x equal to negative 3. Then we will sub the x equal to negative 3 to the equation. So we will get y equal to negative 9. Because of the y equal to 6x plus x squared, the A is greater than 0. So the graph shape will seem like about the U shape. That is for the positive. So for the U shape, the SC symmetry that can get minimum point. So our minimum point is negative 3, negative 9. So next, let us see the graph which form. After seeing the graph, now we can do the B. The B is calling us to find the equation of the tangent to the curve y equal to 6x plus x squared at the origin and the point at x equal to 2. Firstly, we can do the differentiation for the equation and then we can get 2x plus 6. Then we sub the coordinate of origin is 0, 0 into the, after doing the dy dx. So we can get the gradient is 6. Then we can use the formula y equal to mx plus c. We sub the 6 as the m. So we can get y equal to 6x plus c. Then after substituting the coordinate into the y equal to 6x plus c, we can get c equal to 0. So the equation of the tangent for the at the origin point is 6 equal to y equal to 6x. Then the equation also asks us to find the equation of the tangent at x equal to 2. Firstly, we use the x equal to 2 put into the y equal to 6x plus x squared to find out the the value of y. And then we can find out it is 16. So the point is 2 and 16. Then we sub the 2 into the dy dx just now done before, and we can get the gradient is 10 for the point for the tangent at the x equal to 2. Then we can use the y equal to mx plus c. Then sub as m. Then become y equal to 10x plus c. Then we use the coordinate 2 and 16 and sub into the y equal to 10x plus c, and we can find out c equal to negative 4. Then we can form the equation. The final equation is y equal to 10x minus c. For C, the question asks us to, given that the two tangent to the curve is interact at A, find the coordinate of A, then find the enclosed area by the tangent and the curve. So we find the A first. As the question said about the two tangent interact at the A. So we can let it to equal to each other. So for the first tangent is the equation is y equal to 6x. Then the next equation is y equal to 10x minus c. Then we become equal, and we can find about the x equal to 1 and y equal to 6. So the A coordinate is 1 and 6. Then the question also said about the tangent also interact with we need to find the area for the uh, tangent interact with curve at the after that. So we need to find about another coordinate. So our group let the equal to the curve 6x plus x squared equal to the one of tangent is 10x minus 4. Then we can get x equal to 2 and y equal to 16. Okay, after we seeing the the graph, then we need to do the question C. The question asks us, given that two tangents of the curve interact at A, find the coordinate of A, then find the enclosed area. Okay, first we need to do the area below the curve, below the curve. We can call it that big area. So as you see as area from 0 to point B. Okay, that is a area under the curve. So we need to use integration. Integration curve the curve the equation of the curve. So integrate 6x plus x squared, and the limit is 2 to 0, because the point the the big area is from 2 to the 0. So we need to put the limit 2 0. So we get the big area is 14 per 2 per 3. Then we need to find the a the a the point A. So the no the not the point A, the area under the area under the point A, that is triangle. So we use the formula 1 per 2 times 1 and times 6. So we get the 3. Then for B, we use because under the B, that is a trapezium. So we use the formula of trapezium 1 per 2 times 6 plus 16 times 1. So we get 11. So as I say just now, the big area. So we need to use the big area minus the A1 and B1. So 14 per 2 per 3 minus 3 minus 11, and we get the answer 2 per 3. Thank you. That's all. Thank you.